Hello everyone, today we continue learning Redis, and today we'll talk about Redis lists, how to use them, what are those. So let's start. Well, first of all, what I want to say is that if you haven't seen any of my previous videos about Redis, then it's better for you to watch them, because I'll not explain what Redis is, how to set keys, how to delete keys, so basic commands that I already explained in the previous videos. And now what I want to tell you again is that you can run Redis anywhere, but I ran my Redis just in my Docker container. So again, if you wanna do that, then you just can write docker run Redis in your Google and you'll see how to do it. Okay, so today we'll talk about lists and why do we need those. Beforehand, we only used the normal keys in Redis, so we have never tried any other data structures. And when we're talking about lists, we may need them in a lot of cases. For example, if we want to make queues, if we want to just make lists, if we want to have something that will store a lot of values at once. So yeah, list in Redis is just like list, array, container in any other programming language that just contains things. So the real definition of a list in Redis is list is an ordered collection of elements. Yeah, that's just it. So what does it mean? That means that if we, for example, have 1, 2, 3, 4, 5 elements and we put them in a list in that order, list will save the order of those elements. So just like in Python, for example, if you have an array of 1, 2, 3, 4, 5, your array will not change its order. So your elements will stay where they are. That's just a list in Redis. Now let's talk about Redis comments. So again, I ran my Redis in Docker. If you want, you can run it anywhere. If you want to run it in Docker, I'll probably make a video on Docker, but you should just write docker redis run, and that's it. So I opened up my Redis console. Yeah, that's the command that I use. So docker exec, execute it, or if you're on Docker desktop, you can just click on that CLI, and it will open it for you. But it depends on how you want to run Redis, because in the first video I showed you how to run Redis from like an exe file. Now let's run Redis CLI. Let's clear our screen and let's flush DB, because I don't know if I have any keys left from other videos. Okay, so that's my Redis. And if we're talking about simple keys that we use with set command, what we can do? For example, set element 1. That's okay, so we can get that element. But that element is stored as a one big object. What does that mean? That means that if I put 1, 2, 3, 4 like that, and I need to wrap them around in parentheses, not in parentheses, but in those things, you know, in string. And then I'll press enter, I'll see okay. But actually I cannot access any of those elements, because that array, if you know Python, then you know that arrays in Python and in a lot of programming languages are assigned like that. That is not an array. That is just a string. And if we want to really make an array, to iterate through all of its elements, to, for example, insert some things, to append, to prepend other elements, and what we can do is, of course, use lists. So lists are a little bit different from any other data structure that we talked about so far, because we have never talked about any other data structure actually. So the list is the first complex data structure in Redis for us. And what we can do? In lists, we can use command lpush. So lpush, what that command does? It adds an element from the left side. And if you have a list, it just adds an element. But if you don't have a list, it creates a list and adds an element from the left side. So what does that mean? As you can see, when I wrote lpush, which is extended to left push, so L is left and push is push, we need to write two things. Actually, as you can see, there are other elements, but I'll tell you about that. So the first thing is a key. That's the name of your list. And in Redis, list is just like a normal key. So if you see key, it's just the name, just the identifier. For example, list. And then we need to add an element. For example, let's add one element, which is 1. Okay? And as you can see, it returned 1. Actually, if I run my program again, for example, with lpush list2, I'll see 2. So Okay, let's run it again with 0 and we will see 3. Because lpush command, what it does? It returns the length of your list. So in our case, as you can see, it's 1, 2, 3. If I would do it again with, for example, 4, it will tell me 4. But again, it's not the last element that you appended. For example, -10, it will tell me 5. It's the length of your list. Okay, and now if I use keys from O, I'll see that I have element and list. Let's actually delete element and let's see what are the elements of our list. So we can use get list, but actually no, we can't use get list command on a list. And as you can see, wrong type operation against a key holding the wrong kind of value. So what does that mean? Every other data structure in Redis, so actually every data structure in Redis, because keys, like normal keys with set get, are data structures as well. All of them use specific commands to interact with, we need to use specific commands to interact with those data structures. What does that mean? That means that I cannot use get list in order to get all the values from my list. I need to use other commands. And if I go to my web browser, you will see that list, those are all the commands for the list. I don't think that I'll explain all of them because a lot of them are really specific, but today I'll talk about lrange, lpush, ln, lInsert, and lIndex. So what those commands do. And let's start with lpush. So yeah, let's go to lpush first, and yeah, as you can see, lpush inserts all the specified values at the head of the stored list. So what does it mean? That means that lpush values, let me just show you it in Python. For example, we have list 1, 2, 3, 4. And when I write lpush 5, for example, I will not insert 5 at the end because lpush, left push, so inserted as the first element of our list. So lpush will always insert the elements at the start. For example, after 1 I want to insert 10, so I write lpush 10, it will go right here. lpush 11, it will go right here. So we don't add values to the end of our list. That may be a bit confusing for you, but that's how it works. And as you can see, after the version 2.4, it accepts multiple element arguments. So what does that mean? That means that I can just literally write 1, 2, 3, hello, true, false, no, and so on. As you can see now, it tells me 12. So what does that mean? That means that I added all of those elements to my list. And what? Yeah, so you just can write all of the elements that you want in one lpush command. But what I want to tell you is that lpush time complexity is really specific and a lot of people don't fully understand it. So what does it mean? O, big O from 1 for each element added. So on to add n elements when the command is called with multiple arguments. That basically means that you will need to spend O from 1, so only one action in order to add an element to your list. So in order to push it from the left side. But O from n if you add many elements. So for example, if I use lpush list 1, I spend O from 1. So my algorithm is very fast. But of course, if I add multiple elements, 1, 2, 3, 4, 5, I'll need to spend O from n. So O from n elements, we have 5 elements, so O from 5. I think that's pretty obvious because if you add one element and you need to spend O from 1, then if you add 5, 12, 20 elements, then you need to spend 5, 20, and 5, 12, 20 actions respectively. So that's how it works. Now let's clear our console, and that's actually all about lpush. So it adds elements to the left side of your list. Now let's go to the most essential command for lists, which is lrange. So what is lrange? Lrange is basically show me the elements of a list. If, for example, we have keys from O, as you can see, we only have lists. But how do I see the values that I inserted inside of my list? Because now I only can see the name of the list and I cannot use get. I can use lrange list, and then I need to use start and stop. Now I'll use 0 and 10,000, for example. As you can see, it tells me all the values that I inserted. So yeah, 1, 2, 3, as you can see, yeah, all the values that I inserted. So lrange commands just simply gives you the values that you want to receive from a list. If you know Python, then lrange command is just like slices in Python. For example, you say list from 0 to 10,000. Of course, it does not have step as Python does, but still, arrange command just gives you the elements of your list. And actually, as you can see, there is a really strange time complexity. Well, it's not strange, but let's look at it. A lot of people don't understand it as well. O, S plus N, where S is the distance of start of set from head for small lists from the nearest end, head or tail for large list, and N in the number of elements in specified range. So what does that basically mean? That means that if you want to use arrange command, and time complexities are very important in every data structure, in every programming language, but I want to go into them a little bit more in that video, because every REDIS command has a time complexity, and I don't think that I have ever talked about that. But basically, what does it mean? That means that if you have a list 1, 2, 3, 4, 4, 5, 6, 7, 8, 9, 10, and you have, for example, and you want, for example, to get all the elements from 4 to 7. Of course, you can do it, because in arrange command, arrange a list, what you can do is 4, 7, and you get all those elements. Yeah. But what if you want to do it? How your algorithm will execute if you want to do it like that? So what we'll do is we'll start from S. So as you can see, O is S plus N. Let me write it. O is S plus N. What you actually do is, first of all, you go from 0. So that's the first element, and you go to S. So you will spend 4. S is the place where you start your count. So in order to get to where you want to be, so in our case, get to 4, to the start argument, what we need to do is we need to get all the elements from 0 to that start argument. So in our case, we go from 0, 1, 2, okay, actually we'll go to 5 in that case, because we all of the indexes in REDIS lists start from 0, but we wrote 4. So yeah, we go to 5 in that case. But still, S is how many steps you need to take in order to get from 0, or respectively from the end to the element that you want to start on. So in our case, it's going to be 4. So 1, 2, 3, 4. Well, actually 5, but whatever. Okay, it's just the amount of elements that you want to go through from the start of your list to your wanted value. And after that we have N. So N is the end minus start. So in our case, 7, 4. So let me just imagine that that's 4. Oh yeah, that's 4. Like 0, 1, 2, 3, 4. Yeah, 4. 2, 7. 4, 5, 6, 7. To 8. So we need to take 4. Not 4 steps, but 4 plus 3. So we need to take 7 steps in order to execute that algorithm. And that's very important, because typically you have big lists. Well, actually it depends, but if you have big lists, then arrange command cannot work as great and as fast as other commands may work. So you need to always think about that. Now, what I want to tell you is out of range indexes, and I literally don't understand them I literally don't understand them. So let me read. Out of range indexes will not produce an error if start is larger than the end of a list. An empty list is returned. If stop is larger than the actual end of a list, REDIS will treat it like the last element of the list. So basically how I use it. I again don't really know how to use it properly, but what I'm doing is, first of all, let me remove my key. By the way, you can use delete with list, because delete is not a command for only basic keys in REDIS. You can use it with any data structure that you want. So delete list, delete anything that you want. But you cannot use get and set commands. And of course expire and all of those specific commands for keys. So those are for different data structures. Well, actually you can use expire. I think it's expire. Yeah, expire, for example, let me just do push list 1. And then you can use expire list, for example, 5. So our list will expire in 5 seconds. Now I'll write keys O, keys O, keys O, keys O, keys O. Yeah, and keys O. Yeah, okay, let me just wait, and after 5 seconds our list will disappear. But yeah, as you can see, empty array. Well, you can use expire, but there are some commands that you cannot use with this. For example, set and get. Yeah, so That's how it works. But you can use expire, TTL with all of the lists with all of the data structures in Redis because those commands are universal. But now let's talk about out-of-range indexes in lrange. So what does that mean? That means that if you have a list, let's for example do lpush list 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And by the way, if I would do it like that, I will not see 1, 2, 3, 4, 5, 6, 7. I will see 10, 9, 8, 7, 6, 5, 4, because again, lpush pushes all the elements to the first position in the list. So let me do it like that, and as you can see, 10, 9, 8, 7, 6, and so on. So out-of-range indexes, what does that mean? That means that if you want to go from, for example, 10th element to the 6th element, so if you want to go backwards, then you can use out-of-range indexes. If you want to list, like get all the elements in the list, you can, instead of writing like 1000, 10,000, you can write -1 at the stop. Let's do it, and as you can see, the whole list is returned. But let's talk about real out-of-range indexes. So if I'll start from -10, so from the length of my list, and then I can write any value, and that's how I use it. So lrange, give me all the elements from my list with the key list, start from -10, so start from its length, and end on 5th element. So now I'll get, actually I'll get 4 elements, but yeah, because the last argument is not included. But let me just show it to you. Oh no, I get 5 elements. Yeah, because the last argument is included. It's really confusing. So as you can see, oh no, I get 6 elements. Oh no, 5. Or 1, 2, 3. Oh yeah, actually I get 6 elements. Why is that? -10. Oh yeah, I think I know. -11. 5. No, it's the same. Okay, so literally I don't understand how these out-of-range indexes work because they're very confusing in Redis, but what I'm doing every time I need to use them is I just look at the result. So in our case, it's actually very confusing. Why just 5 returns 6 elements? Because it should not be included. Okay, whatever. So lrange list in our case starts from the end of our list and gets 6, as we now know, next elements. So if we want to get 1 element, oh yeah, that's normal. If we're going to get 1 element, we need to use 0. So we need to get from the end of a list to the element 0. If we want to get 2 elements, then we need to use 1, then 2, then 3, then 4, then 5, and so on. But it's really confusing. So yeah, again, indexes, out-of-range indexes in Redis can be used very easily. But if you write anything that is lower than the list of, again, they are really confusing. So yeah, as you can see, if you write anything that is lower than which is lower than the length of the list, so for example, -1, our list has 10 elements, so I need to write -10 to go from the end. Then you just get to the element behind it. So in our case, we got to the element number 1. Yeah, so that's the last element. And then you need to, yeah, it's really confusing actually. I don't understand how it works in any way. So -1, if you go from -1, we need to go to that element. I actually don't know. Yeah, maybe someone in the comments can tell me how they work, but how I use them is I get the length of my list, for example, -10, and then I use 3 to get, as I now know, 4 elements. I thought it was the other way. So if we, for example, write 3, we get only 2 elements, but okay. Yeah, we include 0, so it's normal. But how I use it is I just get -10 elements, and then I put the value that I need, the amount of elements that I need to get. For example, 0 elements, I get 1. 1 element, I get 2. 2 elements, I get 3, and so on. So that's how lrange command works. It's a really good one, but out-of-range indexes, I really don't understand how they work. And again, you need to always think about that O s plus n time complexity of any Redis command, not only of lrange, lpush, and other list commands of any Redis and of any Python algorithm of anything. So if you write something, think about the time complexity because you can improve it. And of course, your algorithm will work better if you improve it. But now let's talk about another command. And I said that in order to use how I use out-of-range indexes, so negative indexes in Redis, is I get the length of the list. But in order to get the length of the list, I need to use len. And it's a really simple command. So yeah, as you can see, there is not much going on here. So len from list, and it tells you how many elements you've got in your list. So let me, for example, push another element. Oh, okay, I'll push list 1. Now if I'll put len, it will return 11. So that's how it works. That's just len command. It's really useful, and what's useful about it is that it only requires O from 1. So big O from 1, it's the time complexity of that function. What does that mean? That means that you can instantaneously get the length of your list. That means that if you have, for example, 1 million elements, then you can use a len command in Python. But the problem is that len command in Python has the time complexity of O from n. So in our case, it will go from 0 to 2, 3, from 1 to 2, 3, 4, 5, 6, 7, 8. So it will go through every element, and it will just simply add 1 to its counter. And after we are finished with our elements, it will just tell us the amount of the elements that we have in our list. But it will just simply go through all of the elements in the container. However, REDIS len command does not do that. I think they store the integer that is the length of the list somewhere, because how can they return the length so fast? So O from 1. If we only like return list dot length, something like that. So yeah, O from n, it's the time complexity of that len function, so it's really fast. And if you have a chance to use REDIS, and again, it's like in SQL. So when we talked about Django optimization, I told you that if you have a chance to use SQL in order to count things, in order to work with the data, then you should use SQL. You should never use Python, JS, or any other programming language, because it will be slower and it will be worse. The same goes with REDIS. If you can, and if you have a function that does something in REDIS, so for example, that moves 10 elements from one list to another, and we'll have that function, it's lpush. So all of those functions, are really useful, and you should use them because they are, first of all, they are written in C language, so they are faster. Second of all, they are faster because of their time complexity and all of those other things. Now let's talk about other two functions, and we'll end with that. So lIndex. So what is that function? lIndex is a very useful function that just literally tells you where your what's the value of the element on that specific index. So for example, let's use arrange list 0 minus 1. As you can see, it tells us all the elements. We need to make sure that we remove 1, so we decrement our value by 1, because again, indexes in REDIS lists, as in almost every programming language, start with 0. So it's not 1, it's 0, 1, 2, 3, 4, 5, and so on. And in our case, if we are using lIndex, what we can do is use lIndex from list and the index, for example, 0. And now we should get 1. As you can see, 1 as the result. If we, for example, lpush, I don't know, lpush list, hello, and then if I use lIndex as well, another time I will see hello as the result. So that's how it works. And now let's look at lIndex time complexity, O from n, where n is the number of elements to traverse to get to the element at index. This makes asking for the last elements a list O from 1. What does that mean? That means that you use it as in, that you use just normal C arrays. So if you don't know, in C programming language, and REDIS is written on C, we have a specific way of going through an array. So in order to get to the element, for example, we have 1, 2, 3, true, hello. In order to get to the element true, what we need to do? We need to go through every element and compare it to the value that we are looking for. In the case of REDIS, what we need to do, because we use not the value but the index, we need to go through every element until we bump into an index that we want to get. For example, okay, that's 0, that's 1, 2, 3. Oh, we want to get index number 3. Okay, that's true, I return you your element. So REDIS time complexity of lIndex function is on, which means that we will need to go through every element until we hit that specific element. So until we get to our specific index. But it also tells you, well, it's just like, an addition that rarely works. This makes asking for the first or the last element. That's very important because in all of the programming languages that I've used before, not all of the programming languages, not in programming languages, but in normal arrays, if the array follows that structure, so you traverse all the elements of your container, then if you ask for the last element, that makes your algorithm big O from N. But in our case, in Redis, if you ask for the first or the last element, we'll only get O from 1. So it's normal for the first element. So if I ask in like lIndex list from 0, as I did it before, then I only need to travel once, so to get my element and return it. But if I ask for the last element, I need to do it as well. So only travel once, so O from N. That's very uncommon because typically you will travel through the whole list and only after that you will return the value. But in Redis, as you know, we have our ln comment returns O from 1. So I am thinking that they store the length of their list somewhere, like in a separate variable inside of their list. So that means that we can actually use lIndex, for example, list, or let me just get ln list first, lIndex list from 11, of course, because ln returns the amount of elements, but we start from 0 when we're talking about indexes. From 11, we'll require O from 1, because I think that they have that variable somewhere, and because of that, they can literally easily easily get to the last element of the list. So they don't need to iterate through all the elements inside of our container. Okay, so lIndex is just a really simple command. As you can see, if I put a value that is inbound, so that is not inside of our list, we not receive any index error, we receive just new, as it is in Redis. So if, for example, I don't have a key, if I use get abc, I return new, but only if I use the wrong operation, for example, get list, then only after that I receive an error. That's actually a very great way for dealing with those types of errors, because if we, for example, have a list, I think it's better to return new, and we just can check it for none. It's not ever great to throw an exception, because a lot of exceptions can be omitted in the code. So I can omit a lot of exceptions because I simply don't know about them. But if it returns new, then I know that, okay, it returns new, I can use if none, but we'll talk about that later, a little bit later. Now let's return to the list. So lIndex just tells you what element is located on what index. And now let's move to the next command. It's a really interesting one, lInsert. So insert command in insert algorithm in any guide, in any programming language, what it does. So, for example, you have a problem. You need to make an algorithm that will insert a value for inside of an array on that specific index. So we need to write value or array value index. But here in Redis, we don't write any indexes. So in order to insert an element, what we need to do is, as you can see, lInsert key before after pivot element. So what does it mean? Let me just arrange my list a little. Let me just see what elements do I have in my list. And in order to insert a value inside of a list, what I can do, lInsert, and I need to write lists, and then I can write before or after. For example, let me delete my list like completely, and then let me push hello list 1, 2, 3, 4, 5. Okay, so now we have our range list 0, -1, we have 5, 4, 3, 2, 1. And in order to insert something between 4 and 3, for example, so in that position, what I can do is lInsert, then key, list, and we need to insert after number 4 or before number 3. Before, for example, before number 3. Our element, our pivot, is not an index, it's the value of an element, 3. And then your new element, so new element, for example. Again, what I'm doing right here, I'm inserting a value inside of my list before the element with the value 3, and it's the new element. Let's run it now. As you can see, it tells me 6, and what I can do is use our range, list 0, -1. As you can see, it tells me 5 for new element, 3 to 1. But if I use lInsert after delete, after 1, for example, 1 is the last element of our list. Last element. As you can see, it tells me 7 right now, so the length of my new list. And as you can see, it's 5, 4, new element, 3, 2, 1, and then the last element. So before and after really tell you where you want to insert your new key. So if you want to insert it before the pivot element, and again, pivot is not an index, it's a value. So you literally give the value of an element, and then you insert that element either before or after that pivot element. And another cool thing that I want to show you is what will happen if we will, or it's not a cool thing, but it's a question. What will happen if I use a list 1, 2, 3, 4, 5, 1, and then I'll push, list, I'll push list, I'll push like that. I'll push list 1, 2, 3, 4, 5, 1. So now my list has 2, and of course, list elements can be equal to each other. So 1, 1. It's not a set. We'll talk about sets in one of the next videos when we'll be completely end with the lists in Redis. But list 0, -1. What will happen if I will use lInsert key our list before, for example, or let me insert it after pivot, I will use 1, and element, new element, like that. So what will happen if I do it like that? Well, you can guess. As you can see, it's 7, so it only inserted once. And if you know that, algorithms, or you read that time complexity, then you know that we only inserted it as the first, so we only took the first occurrence as the result. What does that mean? That means that if you have 2 similar elements, you insert, or your pivot element will be the first element that you'll find with that specific value. So in our case, you can read that, but I'm explaining it to you right now. So in our case, when we traveled through every element, we wanted to insert our new element after 1, we don't need to travel through whole list, because if our list has 10 million elements inside of it, it's not great at all. So 1, in our case, is our pivot element. So the first occurrence of an element that we have is going to be the pivot element for our lInsert command, and for every other command that works with elements as well, because, well, not for every other command, but for the majority of them, because all those commands really, it's very expensive actually to use or to get all the elements into in the results, because if again your list is 10 million elements, then you need to travel through 10 million elements, and you need, moreover, what you need to do is check that the element on that index is equal to your pivot element, because again, we don't write an index right here. I wrote 1, but 1 as a value, not as an element. Again, 1 is a value, and in lInsert there is no indexes in lInsert. There is index in lIndex and other commands. So that's how it works. And again, that was the introduction for Redis lists. I hope you liked it. I hope to make other videos about Redis in the future. There are a lot of commands in Redis lists, but I will not think that I'll explain all of them, but I really need to explain error commands, because we haven't talked about them today. And of course, I need to show you something in Python. So yeah, PyCharm was opened throughout the video, but I have never used it, but whatever. So thank you for watching, and good luck.